Alright people, this is Why No Planets Orbit the Sun by the channel RealLifeLore. Whenever there's video about space or astrophysics related stuff, I just love that video. So RealLifeLore uploaded this video just a few minutes or an hour before. So I'm like, you know what, first I'm gonna react to this one because most of the time I will have some kind of input to give to this topic. So let's watch the video.
This video was made possible by Brilliant. Learn complex topics simply for 20% off by being one of the first 200 to sign up at brilliant.org/reallifelore. Try for a moment to imagine the solar system in your head and tell me what you see. If you're a flat earther, you're probably thinking about something ridiculous that looks like this. But if you're an intellectual, you're probably visualizing something a bit more like this. The sun is at the center, and all of the planets spin around it in...
Alright. About this has nothing to do with the topic of the video, but I want to say it anyway. When people see this, people think, you know what, this is just for the information, this is not realistic. The orbit of the planets around the sun are elliptical, not circular. Then they imagine that elliptical orbit is drastic like that, longer. But that's not true, because most planets and Earth's orbit around the sun makes no difference near circular, just a few degrees elliptical. So it would look like this. If I told most of you that you need to draw a perfect circle using pen or pencil, whatever, there's a chance that you'll draw more of an ellipse than a perfect circle than these orbits are. That's how perfect orbits, the circular orbits, they are. So, when we are children, we are shown things like this. Then we kind of, grow up a bit and we're told that, you know what, it's elliptical. Then we have this misconception that it's drastically elliptical. But it was the first one to begin with. It makes no difference near circular. And also, again, this has nothing to do with the topic, but people think since it's elliptical, the seasons happen because, the Earth is far side away from the sun in an ellipse, and that's when it's winter. When it comes close, it's summer. But that's not it, because if that were the case, there would be 2 summers and 2 winters in an ellipse. That's not the case, because it's tilted. Alright, let's watch the video.
Perfect orbital circles. This map and understanding of the solar system is taught in astronomy classes around the world, and while it's largely accurate for everyday use or knowledge, it's not entirely 100% correct, because none...
Okay, this is not correct. I don't know what he's talking about, but he's talking about the center of the sun. But I also want to add what I just said before. This is, circular, sure, but this is not accurate because it's too close. Planets are not this close to the sun. That's where this is not accurate.
None of the planets actually orbit the sun, and here's why. Let's start with something small and easy to understand and build our way up to the shocking conclusion. Every object has mass, right? And every object has a center of mass, which is the exact center...
now I understand. He's talking about the barycenter. I mean, if that's the case, then this is a misleading title. What is the exact point of the orbit, center of the orbit? That's not the point. Planets still orbit around the sun, regardless of what the actual barycenter of the sun is. He's talking about the barycenter, I'm sure of it. Barycenter is just sun always wobbles, because sun's barycenter is kind of like at the, I think it's edge of the sun or a bit outside of the sun. So sun wobbles in its place. Why? Because, probably rocky planets don't have much of influence, but like gas planets like Jupiter, Saturn, Uranus, Neptune, these planets tug on the sun. So sun kind of, wobbles in its own place. Every planet and even star has a barycenter. Even Earth has a barycenter because of our moon. Pluto has drastic barycenter because of its moon Charon, which is kind of huge compared to Pluto. So I think it's talking about barycenter here.
of all the material that an object is made out of. An object's center of mass is the point where it can be perfectly balanced. Take a ruler, for example, which can be perfectly balanced on your finger right underneath the center of mass in the middle, which also happens to be the ruler's center of gravity. Rulers are simple with their centers of mass actually being in the center, but not all objects are like that. Take a sledgehammer, for example, which has most of its mass on one end. So the sledgehammer center of mass is much closer towards that heavier end. When we scale all of this up to a cosmic scale and begin visualizing two bodies in space, like a moon and a planet or a planet and a star, the same gravitational rules still apply. A planet and a moon, or even a satellite, will share a center of mass the same way that the heavy edge of the sledgehammer shares a center of mass with the handle. Only on this cosmic scale, the planet and the moon will orbit around their center of mass, which is called a barycenter. Take the International Space Station, for example. Theoretically, it doesn't actually orbit the Earth. It orbits the barycenter between itself and Earth, while the Earth orbits around the same point too. But because the Earth has titanically more mass than the space station does, their barycenter is located so close to the Earth's center that it's just fair to say the space station does in fact orbit around the Earth. But Earth has another orbiting satellite that's vastly larger than the ISS, the Moon. The Moon contains roughly 1.2% of Earth's mass, and rather than the Moon zipping around the Earth in a perfect little circle with little effect, the Moon has a big effect. In reality, their orbital pattern looks a bit more like this, with the Earth and the Moon both orbiting around the barycenter in the middle. Unlike the ISS, the Moon is massive enough to cause their shared barycenter to be located an average distance of 4,600 kilometers away from the Earth's center, which is still located inside of the Earth itself, but it's far enough away from the center to where you can notice Earth wobbling around it. In a different scenario, sometimes two bodies will orbit around each other in space that have a similar mass, like Pluto and Charon. Charon contains 12% the mass of Pluto, which is 10 times more mass than the Moon has compared to Earth, and because of that, their barycenter is located fully 100% outside of Pluto. This causes Pluto to fully orbit around the barycenter the same way that Charon does, which means that Charon doesn't orbit around Pluto and can't really be considered a moon as a result. Now, kind of in between the way that the Pluto-Charon system and the Earth-Moon
His wording is wrong here. Charon's orbit center is not Pluto. That's proper way of saying. But Charon does orbit Pluto. I mean, come on.
systems work is the Sun planetary system. The Sun itself is overwhelmingly massive compared to everything else inside of the solar system. It accounts for 99.8% of all the solar system's mass. That is over 333,000 times more mass than the Earth has. About the same difference in mass between a hamster and a sperm whale. Or, well, your mom. Which means that on its own, the Earth-Sun barycenter would effectively be located in the center of the Sun. But Earth, of course, isn't alone in the solar system. Most of that 0.2% of mass that isn't taken up by the Sun is taken up by a single big planet. Jupiter. Jupiter is huge. If you took every single other planet in the solar system and put them all on one side of a scale, and then made exact copies of each of them and put all of those on the same side of the scale, Jupiter would still weigh significantly more over on the other side. So because of all this mass, Jupiter's gravitational pull on everything in the solar system is enormous, even on the Sun. Now, Jupiter is still tiny comparatively. It only contains 1/1000th of the Sun's mass. But even still, that's enough to cause their center of mass to be located just outside of the Sun's surface here.
I knew it.
Which Jupiter
I knew it was surface, not outside of the Sun, but at the Sun's surface.
and the Sun orbit around each other. The Sun orbits around this point the same way that Jupiter does over time. Sometimes the point will be located directly inside of the Sun, and then at other times it'll be millions of kilometers away from it. Jupiter is so massive on its own that it doesn't really orbit around the Sun. But no other planet, including Earth, really does either. The entire solar system also has a barycenter, the center of mass for every object in the solar system system combined. Because the planets are always in different locations during their orbits, the solar system's barycenter is constantly changing position. It can range from sometimes being near the center of the sun to other times being located millions of kilometers outside of the sun's surface. All of the matter in the entire system is always orbiting around this changing point, so none of it is ever orbiting.
That's because of, all the planets are not always at the one side of the sun. So, tugging of the, tugging between each other is kind of force is changing. Half of the planet one side, half are the other side. Tugging forces will kind of be lower.
Around the sun itself. Everything in the solar system, from the tiniest ant to you and all the way up to the planets and the sun, are interconnected, and everything has a direct influence on everything else. Some influences are small while others are huge, but our solar system is not a simple series of spinning circles. It's a complex cloud of stuff all moving around at the same time, where even the smallest thing has an influence on the biggest thing. The way that the sun wobbles around the barycenter in the middle also has fascinating implications for astronomers, because it's exactly how we detect invisible planets around a very distant alien star. By detecting a distant star's wobble around a barycenter the same way that our sun does, astronomers can naturally infer the existence of at least one big planet around it causing that to happen, just like Jupiter does with our star. But discovering a faraway planet around a distant star is much more complex than just that. There's a lot more that goes into it that I just don't have time to talk about in this short video, like understanding
It mostly comes down to observing light.
mass, simple physics, Newton's laws, gravitational forces, orbits, and so much more. But all of those things you can learn about in extensive detail by using Brilliant and taking their course on gravitational physics. I never went to school for astronomy or physics or even anything remotely related to STEM. I've always struggled my entire life with understanding.
Alright, go to brilliant.org/RLL and support the channel RealLifeLore. So yeah, I was right about it. He's talking about the barycenter. You could technically say this is true, but the wording is wrong. The orbits, all the orbits center is not the sun, but planets still orbit the sun. I mean, come on. So the wording is a bit weird here. But yeah. This was an interesting video. RealLifeLore always has great videos, especially space related. Alright, if you like my reaction, please don't forget to like and subscribe.